Hey, this is Horner, and this is energy question, free response question number 1. So we have a bowling ball, and it is attached to a string, and it swings down, and the string is not very good, and so there's a chance that it could break. The first thing that they want us to do is on this dot, they want us to draw a free body diagram. So we have to remember, because it's connected to a string, that it has some sort of centripetal acceleration, which means that there is always a greater force going towards the center of the circle than anything else. Be careful, it says that it wants us to draw the free body diagram when it is in a vertical position. So not this way, they trick you. It means that the ball is down here and the string is connected this way. If that's true, we're going to have mg pointing down, so we'll just go ahead and put mg here. And then pointing up is the force of tension, and so we'll put ft at this point. So that answer would give you all the points that you would deserve for that part. So let's go ahead and move on to the next. In this one, they want us to write an equation in terms of m, l, g, and t, and v. So we can't use any other letters in those. They want us to do Newton's second law. So remember, that is just the sum of the forces is equal to, and remember, because this is moving in a circle, it's got to be MAC. So let's look at all the forces. We're going to say that up is positive. Okay, so if you draw this, don't put it anywhere near this diagram, because if you put it on the diagram, they will not give you points. So probably a better thing to do, instead of putting it here, is to put it down here and just say up is positive. And that's for you more than anything else. So this is going to be T is up, it's positive, minus mg. And notice I wrote T and not ft, because ft would not give you the points. And that's equal to m. And we can't use AC, you don't see it, but we do know that the centripetal acceleration is equal to v squared all over r. Now that we have that, we notice, can't use r, we've got to use L, so we'll go back and we can get rid of the r, and instead we will put in the L. Now we have everything in the terms that they want them for. They also need us to go through and give a conservation mechanical energy statement. So we know that when the ball is at the top, up here, it has potential energy due to gravity, and then down at the bottom, it has kinetic energy. So we'll say then that the potential energy is equal to the kinetic energy, and for this situation it's mg, don't use h, you have to use L here because it told you could only use these letters, and that's equal to 1/2 mv squared. If you wanted to, you could reduce this down. I would just leave it because you really don't need anything else in that one. Let's go ahead and move on down. Here it says it's repeated with the same type of string, but the length of the string is different. Student A is afraid that it'll break if it's made longer, since that results in the ball moving faster at the bottom. Student B is concerned that that ball will break if the string is made shorter. So what we have to do is go through and think about which one of these are right. Neither of them are. That would be the correct answer. However, you could get partial credit if you answered A. A would be okay because in the energy equation, okay, so you have to use the energy equation. A greater speed would give a greater tension. And so we know that that would be okay to do. For B, if you said F is equal to mv squared all over r, okay, if you have a shorter r, you're going to have a bigger F. And so basically what they're saying here is if I have 1/1, that would give me a force of 1. But if I took that radius and made it smaller, made it 1/2, that's going to give me a force of 2. But that's only part of the story. This one over here, if we do mgl is equal to 1/2 mv squared, you could try to reason that the longer the length, the faster it goes, and the faster it goes, if this is really fast and you get a big force here. Neither of those is right. What we have to do is we have to go back to the equation that we were looking to up here, and we'll see that if I solve for speed for this particular energy equation and get rid of the m's, I'm going to have 2 times gravity times the length. And our overall equation for tension is tension minus mg. If you remember, was equal to, and then we can pull this back down so we can see, well, we'll just say it's mv squared all over L. Let's substitute this into the V. And if you do that, you get T minus mg is equal to 2mg L all over L. And so those L's cross off. And so now your final equation is T minus mg is equal to 2 times mg. And that's really it. So you wouldn't want to do anything else, but this is the ultimate answer. And then you would need to provide this with some sort of written explanation. If you just draw all this, you've not explained it. So be very careful that you actually go through and explain. Same thing here. You don't really need to explain this because it doesn't ask you to do that. Here it says justify. This one just says a statement of conservation of mechanical energy, so you can just do this. And then if we move up, a statement, so this is a statement. So that's kind of how you do it.